Understanding vector algebra. Here we have point-to-point vector, and we'll now understand how to find magnitude and direction of our vector. A. Sketch vector AB whose tail is at -3, 1 and head is at 1, 4. And part B is determine magnitude and direction of AB, right? So we will do this problem now and understand how to find magnitude and direction of given vector. So let's do the first part first. It's a point-to-point vector since we have given tail and head. Now tail is at -3, 1. That means -3, 1 is this point for us. And head is at 1, 4. So 1 and 4. So that is the point for the head. So joining these two, we get our vector, right? So that is our vector. And we'll write this vector as AB. So here is A for us and that is B. Correct? So that is our vector AB. Now part B is determine magnitude and direction of AB. So let's try to find how to find magnitude of this given vector. Now to find magnitude, what we can do is we can resolve this vector into its components. Right? We can make a right triangle. So we'll do resolving into components later. But what we will do here is we'll form a triangle. See, we see two things here. Now, let's try to understand how to find magnitude of this vector. So magnitude is basically distance between A and B. Now we can use the distance formula, that is change in their x position, square of that, plus change in their y positions, square of that, will give us square of the magnitude. And then we will square root and find the magnitude of the vector. So that's a good way of doing it. So let's do that. So what we will do is we'll make a right angle triangle here. Right? And from here we can see what is the change in x position. That means what is x2 minus x1. Once we find that, we can square it. Similarly, we'll find what is change in y position. That is y2 minus y1 and we'll square it, correct? With that, we'll get square of AB. But we need just magnitude of AB, so we'll square root this, right? So that is as good as Pythagorean theorem, correct? So applying Pythagorean theorem to this right triangle. And what do we get? We get magnitude. In vectors, we write magnitude with these bars, the absolute bars and the vector inside. So that is how you have to write magnitude, right? Now this means we are only talking about magnitude, no direction, correct? That's what it is. Now you can do your calculations, which is square root of x2 minus x1. That means 1 minus minus 3. 1 minus minus 3 whole square plus y2 minus y1, right? 4 minus 1 whole square and square root. So that gives us square root of 1 minus minus becomes plus and is 4. 4 square is 16, so we'll write 16 plus 4 minus 1 is 3. 3 square is 9. I have purposely taken these points so that it becomes easier for us to do calculations, right? Now, most of the time you need a calculator, right? I will also need a calculator to find direction. Anyway, I'm just trying to avoid it as much as I can. 16 plus 9, is 25. And square root of 25 is 5. So the magnitude of our vector is 5. That means this distance from A to B is 5 units, correct? That's how we find magnitude. Now let's see how to find direction, part B. Second part of part B, direction of AB. Now for that, we need help of what we learn in trigonometry, right? Direction we can give with an angle. So let's say this angle here is theta for us, right? So let me say this angle is theta. So finding direction is, in a way, saying that what is this angle with the horizontal? That's one way of saying direction. The second way of telling direction is what is the angle of our vector with the north, right? Because in navigation, many people, especially sailors and aircrafts, we use direction from the North Pole. They had been using it for ages. So two ways of giving direction. One from north, second from east, or the horizontal line, right? In any case, we need to find this theta. And to find theta, what can we do? We can use tan theta, right? So we know tan theta is how much? So tan theta is change in y over change in x. Let me call here change in y, delta y equals to, we just calculated, 4 minus 3, which is 3. You can count 1, 2, 3. And change in x is equals to 4, right? You can count 1, 2, 3, 4, right? Tan theta is change in y over change in x, right? Let me write delta y over delta x. That means 3 over 4 for us, 3 over 4, right? If tan theta is 3 over 4, theta is tan inverse of 3 over 4, correct? So let's find tan inverse of 3 over 4 using a calculator. So we can do 3 divided by 4 and then shift tan inverse of our answer, 36.869. 36.869. So I'll just round it to whole numbers. Let me write this as 37 degrees for the time being. So that is our angle theta.